Have you ever wondered why software has become so important? It was once a complex field known only to a few experts, but today it's a concept that almost everyone has some contact with. Everything from our phones to our cars to even the light bulb in our homes runs on software. So, what we call the software world has actually become our world, and this is where a very interesting debate arises. Some say software should be taught in schools, just like reading and writing, but others say there's no need to learn programming anymore. Thanks to artificial intelligence, everyone will be able to write software using speech. So, which one is correct, or are both right to some extent? We'll explore this topic in this video. Let's first ask ourselves this question: why do so many different opinions emerge? There's a very simple reason. The world of technology isn't just about science. It's also influenced by economics, strategy, and even psychology. To better understand this issue, let's consider NVIDIA's CEO, Jensen Huang, as an example. He constantly talks about how artificial intelligence will change the world. Why? Because the more AI used, the more NVIDIA chips are sold. In other words, this rhetoric is actually part of a marketing strategy. On the other hand, there are companies like JetBrains that produce software development tools. They also say, learning to code is the foundation of the future, because it's directly related to the sales of their products. In fact, there's a commercial interest behind both of these extreme views, and often these discourses aim to manipulate perception rather than reflect reality. But the issue isn't just commercial, it's psychological as well. People view their ideas as part of their identity. When someone says they don't need to learn to code, it's not just an opinion, it becomes their way of defining themselves. When someone criticizes an idea, they actually feel criticized. That's why they immediately become defensive and protect their own position. The same goes for communities. Belonging to a group gives people a sense of security and identity. When that group's ideas are criticized, a person feels as if they're being attacked. As a result, when both psychological and economic factors combine, it becomes quite normal for hundreds of different opinions to emerge on a single topic. So, where is software really heading? Let's look back to the past to understand this. When computers first appeared in the 1950s, the entire concept of interacting with a machine was almost alien to most people. These early computers were massive, room-sized machines, filled with banks of vacuum tubes, relays, and wires that required constant attention. There was no graphical interface, no keyboards, not even the concept of software as we know it today. Programming a computer meant communicating directly in binary zeros and ones, the fundamental language of the machine. Each operation was a literal wiring of circuits or punching sequences of holes in cards, and a single misstep could mean hours of debugging physical hardware. At that time, coding was less about logic or creativity and more about precision and endurance. It required an almost ritualistic understanding of the machine's architecture. The very word coding didn't carry the abstract, almost artistic meaning it has today. It was a mechanical, highly specialized task that only a handful of engineers could perform, and each program was a fragile, delicate construct, often unique to the specific hardware it ran on. Then came the 1960s, a revolutionary decade for computing. During this period, programming languages such as Fortran and C emerged, allowing humans to communicate with computers in a way that was no longer purely hardware-centric. Suddenly, instead of commanding individual circuits, programmers could express their intentions in abstract syntax and structured instructions. Software became a form of expression, a bridge between human thought and machine execution. This abstraction allowed developers to focus on solving problems rather than managing the minutiae of the electronic circuitry. Programs could now be reused, modified, and scaled in ways that were impossible before. Moreover, the concept of compilers arose, translating human-readable code into machine language, making software development more accessible and reducing the enormous barrier to entry that had existed in the 1950s. It was a period where computing began its transformation from a scientific curiosity into a practical tool with potential applications in business, science, and government. By the 1980s and 1990s, software had evolved far beyond mere functionality and began to prioritize human interaction. Personal computers were becoming household items, and software needed to be usable, not just technically accurate. This era saw the emergence of user interfaces designed to make interaction intuitive and visually coherent. Concepts like error management, which ensured that programs could handle mistakes gracefully without crashing, And data structures, which allowed information to be organized efficiently, became central to software design. Programming became a discipline that blended engineering precision with an understanding of human behavior, a craft where developers had to anticipate how users would think, act, and even make mistakes. Software was no longer just a tool, it became an engineered experience where reliability, usability, and performance needed to coexist. Industries began to recognize that good software could be a competitive advantage, and the role of the programmer shifted from a machine operator to a designer of systems that could interact with humans seamlessly. In short, these decades marked a profound evolution from the raw mechanical logic of the 1950s through the abstraction of the 1960s to the user-focused engineering of the 1980s and 1990s. Each stage built upon the previous one, transforming software from a rigid technical necessity into a medium through which humans could extend their creativity, solve complex problems, and begin to shape the modern digital world. This journey highlights that programming has always been more than a set of instructions for a machine. It is a reflection of how humans think, organize, and interact with the systems around them. The internet exploded in the 2000s. With websites, search engines, and mobile apps, software was no longer just a tool, but life itself. And today is the era of artificial intelligence. Artificial intelligence is the next evolution of software, but this evolution is a little different from its predecessors, because this time technology has transformed software from a tool into a system that writes its own software. Today there are AIs that design AIs themselves. Just think, while humans once wrote code line by line, now even the systems that write that code are created by another AI. In other words, humans are now merely a guide in the production process. They tell us what to do, but the system figures out how to do it. It's like a child developing their own ideas by building on what they learned from their teacher. Moreover, these self-designing AIs aren't just theoretical. Google, OpenAI, and many research labs are already working on systems that train, optimize, and improve other models. In other words, the evolution of AI is no longer linear. It has entered a rapidly self-reinforcing cycle. But this raises the question, if AI can do everything for us, why should we still be learning to code? Isn't that a very logical question? But the answer is actually a bit deeper. Now think about children. They have AI solve math problems. Their results are correct, but they don't know the operations at all. In other words, they don't understand how they're solved. That's what coding is like. AI can write code for you, yes. But if you don't know how it works, you can't manage that code, improve it, or find its errors. In that case, you're just a user, not a producer, and the value of something everyone can use diminishes over time. In my experience, while working on a project recently, I witnessed that currently popular AIs couldn't resolve some compilation errors. These AIs, at least for today, are excellent at generating code snippets, handling straightforward tasks, and even suggesting efficient solutions for common programming problems. However, when it comes to larger, more complex projects, their limitations become apparent. This reveals an important truth. While AI can accelerate development and reduce repetitive work, it cannot replace the deep understanding and intuition of a human developer. When developing large projects, knowing how to structure your code, anticipate potential issues, debug intricate errors, and optimize performance remains essential. This is why mastering the fundamentals of programming is still crucial, not just to write code, but to guide AI effectively, evaluate its output critically, and ensure that the software you create is reliable, scalable, and maintainable. By the way, learning to code isn't just a technical skill, it's a way of thinking. Just as math isn't just about numbers, it's about logic too. Coding improves thinking, planning, and problem-solving skills. Furthermore, learning to code isn't as difficult as it used to be. There are resources, videos, and tools for everything. Artificial intelligence can also help people in this process. In fact, I think in this new era, it's not about learning to code, but about learning how to code with artificial intelligence. I'm talking about AI-supported thinking skills. A developer must now be able to think like an architect. They must know when to seek help from AI and when to intervene manually. Those who can strike this balance will make a difference in the future, because the value of software will no longer be measured solely by what you do, but by how you do it. So in short, AI didn't kill software, it just changed its form. And this change hasn't completely abandoned us. On the contrary, it's forcing us to be smarter. So my point is this: people shouldn't fear AI, but they shouldn't blindly trust it either. They should learn to use both together. AI, rather than replacing us, it's challenging us to think smarter, to understand deeper, and to create better. Software doesn't die, it just evolves. And those who can keep up with this evolution will be the ones who shape the future. So, do you really think coding will become unnecessary in the future? Or will the human power to learn and create still be the biggest difference?